Hi everyone, my name is Hannah Byrne, and for this video we will be discussing artificial vision, more specifically the types of bionic eyes that are available in the United States today, how they work, and what people can see when they use this product. So the first thing you should know about bionic eyes is that they are not prosthetic eyeballs. They're actually glasses that a person wears to restore their vision. They were first deployed in 2012, and currently they're used to restore vision for age-related macular degeneration of the eyeball. They can't cure blindness or other eye diseases yet, but hopefully in the future that'll be something that is more widely available. We're going to take a look at the Argus 2 retinal prosthesis system. It was developed by Second Sight Medical Products, and the reason we're looking into this one specifically is because it's the only commercially available FDA-approved bionic eye in the United States. And as popular as you might think bionic vision is, it's only used by a bit over 350 individuals worldwide, and it is incredibly expensive. This prosthesis system costs $150,000, and as you might have guessed, it's not covered by any insurance agencies. Now we can dive into the technical structure of the bionic eye. The glasses have a mounted camera which transmits data to an external body-worn processing unit, which you can see in the picture here. It's that box. Data is then processed and then sent to the implanted system through an external wire, where it reaches the implanted receiver, which is placed on the back of the wearer's head, and this passes a signal to the retinal implant. Then from here, an implanted electrode array stimulates the retina, which allows those signals to pass through to the vision processing centers of the brain. This image here gives us a better visual on the implanted receiver. As you can see, it's placed just behind the ear, and then it sends those signals to the implanted electrode array, which sends those signals to the brain. And here we can take a closer look at the electrode array. If you glance over at that patch on the back of the eyeball, that actually is going to emit small pulses of electricity, which then stimulates those retina cells, and then that information is passed along the functioning optic nerve to the brain, which allows a person to perceive patterns of light. Now you might be thinking artificial vision and natural vision are going to look the same, but there are actually some huge differences that cause artificial vision to look much different than what a normal seeing person would see. The Argus prosthesis system has 60 electrodes, but experts estimate that it would take about 1 million of these electrodes to replicate natural vision. So because of these limitations, it's impossible to replicate color, and images are seen more as a series of bright flashes rather than a consistent visual representation of what's happening. One user reported that it looked like looking at the night sky where you have millions of twinkling lights that almost look like chaos. These 3 images give us a bit of insight as to how someone with artificial vision would see the world. The image on the left shows how a normal person perceives the world, minus the color. The image in the middle shows the same scenario, but how the camera is picking it up. And the third image on the right shows how someone with artificial vision would perceive this specific scenario. As you can see, artificial vision is not very detailed, but it does enable people to discern light, movement, and shapes, and some users function well enough to read large print books and cross the street on their own. There are obviously still a lot of improvements to be made on this device. Experts are hoping that by increasing the amount of electrodes on future devices, a user's perception will become much more clear. In May 2020, Second Sight Medical Products began planning for the release of the Orion Visual Cortical Prosthesis System. The release of this new system is aimed to provide artificial vision to individuals who have become blind due to a wider range of causes, including glaucoma, diabetic retinopathy, optic nerve injury or disease, and eye injury. They also aim to increase the amount of electrodes from 60 to 240. This increase in electrodes should allow users to have a more detailed perception of the world. Overall, I think artificial vision has a lot of potential. I'm hoping that in the future, these devices will become as popular and advanced as the cochlear implants that have restored the hearing of so many people around the world. Sight is becoming increasingly more and more important with the rise of the technological age, so it's going to be really interesting to see how far this product will come.